Okay, guys, so today we're going to talk about how probability changes with dependent events. These are events that depend on each other. Makes sense, right? It's when the probability changes because something happens. Okay, so let's look at some examples. A box contains 3 US coins, 2 dimes and 1 quarter, and 2 Canadian coins, 1 dime and 1 quarter. A coin is drawn randomly. Without replacing the first coin, a second coin is then randomly drawn. So a little bit of language here, you guys, that we need to be conscious of when we're reading these. So let's go ahead and underline or highlight if you have a highlighter. Without replacing the first coin, a second coin is randomly drawn. All right. What is the probability of drawing a US coin on the second draw if 1, a US dime is drawn on the first draw, and 2, a Canadian quarter is drawn on the first draw? Okay, yikes. All right, so let's take a look at number 1 first. Okay. So the probability of drawing a US coin on the second draw if 1, a US dime coin is drawn on the first draw. Okay, so if the first coin is a US dime, then the probability of drawing a US coin next is 1/2. Why is it 1/2 though? Yes, Maddie.
Because there are 5 coins and there are 3 US coins. So if you take one away, then it's 2 on 2.
Okay, great job. So let's take a look. If we so our first probability of drawing a US coin is 3 out of 1, 2, 3, 4, 5, right? Oh, my pen's doing the funky things today. All right, so this is our first draw, and we don't really care about that, but we're gonna draw a dime out, and now that dime is no longer there, right, you guys? Go ahead and take notes with me, please. Make sure you're writing down anything you see me write down. So if the dime is no longer there on the second draw, how many coins do I have in the mix? Kinsey? If I already drew, yeah, I have 4, right? So I have 4 outcomes possible. Good. So number 1 says, if the first coin is a dime, the probability of drawing a US coin next. Now I've got how many dimes and how many quarters do I have in the mix there now? I already drew 1 dime out. So how many dimes and quarters do I have? Yeah, Tyler? Well, I started with 2 dimes and 1 quarter, 2 US dimes and 1 US quarter. I drew 1 US dime out. So now I'm down to 1. So how many US coins do I have now? I have 2. So 2 out of my 4 are US coins. Therefore, the probability of drawing a US coin on the second draw is 1/2. Are we seeing it, you guys? We just have to think through the story a little bit. We have to think through the sequence of events. All right, so that's 1. Okay, so number 2. Now, what if a Canadian quarter is drawn on the first draw? So first of all, let's go back and think about what's happening on the first draw. We've got 2 Canadian dimes. I'm sorry, 2 Canadian coins. So 2 out of 5 are Canadian on my first draw. I don't really care about that much, but I just want to write it down so we know what's happening. Now on the second draw, if we've picked 1 US dime already, I need everybody showing me star right now. I know that this is hard, or maybe for you it's easy and that's why you're slouching, but we need to engage because you'll have to trust me that this is a hard topic. Thank you. Austin, please take that. Okay, so we're down a US dime. How many coins do we have left in the box, you guys? How many? How many? 4. I have drawn 1 US dime. What's the probability that a Canadian quarter is drawn? Now, have the number of Canadian coins in the mix changed at all? Did I pick a Canadian coin the first time? No, so I picked a US dime. So my number of outcomes has changed. It's down to 4, but still the same number of Canadian quarters in there. All right. So, drawing a US coin on this US coin on the second draw. Okay. I'm sorry, I messed this up a little bit. I was thinking back to the first thing. We did pick a Canadian quarter. So yes, I'm sorry, you were right that the number of Canadian quarters is mixed up. But we still have all of our US coins in there. So what are the chances now that I can draw a US coin? Elijah? 3 out of 4. Good job. Okay. All right. Or actually, let's do the same one, but we're going to use our possibility chart. Grab my notes here. Okay, so same problem. Still have 3 US coins in the mix, plus 2 Canadian coins. And we want to just do this a different way. It says without replacing the first coin, a second coin is then randomly drawn. What is the probability that both coins are US coins? All right, so let's take a look. Here's our possibility, and we're going to fill this out a little bit different. It's already filled out for you. But if you look at the way it's marked, so we've got, these are our dimes. Maybe it might be easier because they're just really hard to see, aren't they? Those are US dimes. This is a Canadian dime. This is a US quarter. This is a Canadian quarter. Okay, so let's mark where we've got one, or the possibilities that both coins are US coins. All right, so here is the possible outcome. Why is this? Notice that I've got a blank space right here. Why do you think that's blank on this possibilities chart? Remember, I'm leaving the coin out of the box. So why don't I have an X or a circle on that spot? Alex? Exactly. So I can't draw the same dime, right, you guys? I already drew it out. So that's why we have blanks on these types of charts when we're talking about dependent events. I can't pull exactly the same dime out. So we're not going to put an X there because that's not possible, right? So we put an X here. Just do this with me, you guys. Here, here's a possible. These are all of our possibilities. Notice this pattern right here, you guys. That's one nice thing is with these dependent events charts, usually you're going to see a pattern and it becomes really easy to fill out the chart. All right, now let's circle the times when both coins that are drawn are US coins. Okay, there's one here and there's one here. And then there's dime, dime, dime quarter, dime quarter, dime quarter. And these are Canadian coins right here. So that whole row would be crossed out and that whole row would be crossed out. So what's the possibility that both coins are US coins, even if we leave one out? What's the probability? And right now, all we're doing is we are just counting the circles. So we want to know how many outcomes there are, and we can do outcomes really quickly and easily. We can see that it's going to be 25 minus these, impossible outcomes in the middle here. Alda? Okay, 6 out of, whoops. 6 out of what? Well, it's not 25 because we remember we have these squares here that those are not outcomes, are they? 6 out of 20. Good job. And of course, we would simplify that. So instead of 6 out of 20, you would say 3 out of 10. Good. Okay. So are these independent or deep? Well, it already shows you. These are dependent events. Okay. All right. So let's do another method. Let's use the mathematical method. All right. What's the probability, let me erase some of that the first coin will be a US coin? We just did this a moment ago. What was the probability that the first coin would be a US coin? Elijah? It wasn't 3/4. How many did we start with? So we're just drawing the first time. We've got all the coins in the box. No? So we've got we've got 2 dimes and 1 quarter. Kinsey? 3/5. Now, we're going to multiply that. Remember, we multiply for probability. Okay. So for the second event, we're down 1 US coin and we're down 1 coin overall, right? So first of all, how many outcomes do we have on that second draw? How many coins in the box, you guys, if we've already taken one out and we put it aside? Ray? No, we started with 5. We started with 5 coins in a box. We start with 5 coins in a box. We take out 1 US coin and put it aside. How many coins do we have left in the box? Okay, good job. We got 4 coins left in the box. Now, remember that the coin that we took out, that was a US coin. So how many US coins now do we have in the box? Annie?
3.
We started with 3. We took 1 US coin out. What is it? 2. Good. Okay, so now we're going to multiply 3/5 times 2/4 or 1/2. What's our probability? Should be the same, you guys. Yep. Which is what, Finn? 3/10. Good. We can do some cross canceling there to get to 3/10. Okay, let's do a couple more, or at least one more, then I'm gonna let you guys do a Toyo. Here we go. A spinner board consists of 6 equal sectors. It is spun twice. Are getting yellow on the first spin and getting yellow again on the second spin independent events, guys? Yes or no?
Yes.
Yes, they are independent events. What's the probability of getting yellow on the first spin? Liam?
1 out of 6.
1 out of 6. Great job. What's the probability of getting yellow on the second spin? Gabby? 1 out of 6. Great job. Okay. Now, what do you think the probability would be of getting yellow twice in a row? Alex?
112.
Well,
136.
thank you. 136. Good job. Okay. Next one. 6 cards are numbered, but what I want you to notice here is that yellow in this, oopsies, go away. Yellow is the same probability for both spins because those are independent events. If they're dependent events, would the probability change? Yeah, yes, it would. 6, like the next question. 6 nut cards are numbered 1, 2, 3, 4, 5, and 6. 2 cards are drawn randomly. No replacement. Let's highlight that. No replacement is made after the first card is drawn. Are drawing a 6 as the first card and drawing another 6 as the second card independent events? Yes or no, class?
No.
No. Good job. Okay. So let's figure it out. What is, oh, for some reason I'm missing this in my notes. That's really weird. What's the probability of drawing a 6 on the first draw? Just the first draw. How many cards do we have? We have 6, right? So the probability of drawing a 6 would be 1/6. Good job. How about drawing a 6 on the second draw? What's the probability of drawing a 6 on the second draw? We've already drawn the 6 and we didn't replace it. So what's the probability of drawing a 6 on the second draw? Hala? It's 0. Exactly. Yeah. These are dependent events. If I took the 6 out, there's no longer a 6 in there. Take notes in pencil. Do you have your pencil with you? Yeah. Okay, please take notes in pencil. So these are dependent events. Good. Charlie. Oh, a good point. That is a mistake. Yeah, 0/5. Okay. All right, let's do another one. There are 3 books on a shelf. Hans randomly selects 2 books from the shelf blindfolded. No replacement is made after the first book is selected. Okay, underline that. When we're doing word problems, you guys, it's going to be helpful for you if you can like pick out keywords so that you can identify what kind of word problem it is going to be. So that's why I like to have you underline or highlight. After selecting a fiction book as the first book and selecting another fiction book as the second, are selecting a fiction book as the first book and selecting another fiction book as a second book. Are those independent events, you guys? Do the number of books change after the first book is drawn and it's not replaced?
Yes.
Yes. So are they independent or dependent? Dependent events. Good. So these keywords right here, you guys, no replacement is made. That I want you to clue into like, oh, this is a dependent event situation. Okay. So go ahead and write that down. That's what that language means, is that you're going to be fixing events. And everybody should be writing down what they see me write down. So we should be writing down what you see me write down. Okay, we're on the next problem now. All right. So if the first book is fiction, or let's say it's that blue fiction book, then the probability that the second book is a fiction book is, well, let's see. Okay, let's look at this row. If the first book is blue, then the probability is, let's see, you know what? It's not easy to tell. I have to look at my notes. Let's write fiction, fiction, nonfiction. This is fiction. The red ones are fiction and the white ones are nonfiction. Does that help a little bit? Looking at those and I'm like, I can't tell. Okay, do you guys have mistakes in your notes? Does it say spinners? Does it say fiction on first pick? Good, we fixed it then. Okay. All right, well, let's look here. Okay, so what is the probability that he's going to pick fiction on the first pick? What is it, Anthony? Okay, what's the probability? If he picks a fiction book, what does the probability become then if he picks to pick on the second pick? Because remember, he would now like not have a fiction book on the shelf. Nora? It would be 1/2. Okay, so good. So let's do this. So if the first book is fiction, blue, okay, so there would be a 2/3 possibility that he would pick fiction on the first book. Now, the probability that the second book is a fiction book would then be 1/2, right? So what's the probability that he'll pick fiction, fiction? Kinsey? 1/3, good job. Okay. Okay, if the first book is the red fiction book, do your guys say fiction or does it have the boxes? It has the boxes. Yeah, I need to redo the notes here because my notes are different. Okay, so we'll just cross off the second one because we already answered the question for fiction, fiction, and both the blue and the red were fiction. So that's what we found for. All right, so are those independent or dependent events? Dependent, good. Okay. Let's go on. Okay. The names of 5 students are put in a hat. Miss Maria picks 2 names randomly. Find the probability that A, the first student, is a girl, and let's go like that. Okay. And B, the second student is a girl, given that the first student is Mia. And then C, the second student is a girl, given that the first student is Paul. D, are picking the 2 names independent or dependent? Well, let's just answer D first. Are those independent or dependent events? Dependent. Go ahead and fill that in for D, and then let's go back and do the specifics. All right, now let's say she picks, well, let's find the probability for A first. What's the probability that the first student picked is a girl? First of all, how many possible outcomes do I have? That's the number of students. Kendall? Good. Out of those 5, how many of those kids are girls? Gabby?
3.
Yes, great. Okay, so 3 out of 5 are girls. B, the second student of girls is a girl, excuse me, given that the first student is Mia. So let's cross off Mia. Mia's been picked. Now, how many kids do I have in the mix? Annie? Good. Oh. Come on. There we go. Okay, I've got 4 kids in the mix. How many girls do I have now that Mia's already been picked? Ainsley? Good. So that answer is 1/2. Okay, letter C. Let's erase our crossover Mia. Now the second student is a girl, given that the first student is Paul. So let's cross Paul off. Paul's been picked. How many students do I have now that Paul's been picked? Wait, Mia's back in the mix. This is a different situation. I have 4. And the question is, the second student is a girl, given that the first student is Paul. So what is my probability, Tyler? 3/4. Great job. Okay. Is that starting to come together?
Yeah.
Yeah? Are we getting a little bit more confident, you guys? Okay, oops, let's go on. All right, so let's take a look at using a possibilities chart. All right, so same problem. The names of 5 students are put in a hat. Here's my first student up here, and then my second student right here. Miss Maria picks 2 names randomly. Mr. Green randomly picks the names of 2 students from the same hat. Find the probability that both the students are chosen are girls. Can I pick Mia, Mia? Can I pick Paul, Paul? Can I pick Jacob, Jacob? So that's why this middle diagonal is blank, is because those are not possible outcomes. So how many possible outcomes do I have? What's just the number shown by the chart there? Ashley, can you tell me? No, the possible outcomes are everything that could possibly happen. It's where the X's are. So one kind of quick way you can do this is like multiply the chart, multiply the rows. We have 5 times 5, which is 25. But then we blocked off 5 because those can't happen, because that would mean picking the same kid twice. So 25 minus 5, 20. Okay, so we have 20 possible outcomes. What are the possibilities? Now we need to go through and circle the actual possibilities. Let's start here with Mia being the first student. Mia and then Paul, is that a possibility? Mia and then Jacob? The question is, find the probability that the 2 students chosen are both girls. How about Mia, Ellen? Yeah, so we would circle that one. Mia, Nora? Yeah, we would circle that, okay? And then we would skip Paul and Jacob's row because they're not girls. So we don't have to look at that row. How about Ellen and then Mia? Is that a possibility? Yep. Ellen and then Nora? Yeah, but we wouldn't circle Ellen, Paul, or Ellen, Jacob, and then Nora, Mia, and Nora, Ellen. So out of 20, how many possibilities are there of what we're looking for? Austin? Yeah, 6 out of 20, and that simplifies to 3/10. Now, is that this? Oh, I guess we didn't do it this way before. So the probability is 3/10. We could also write that as a decimal. Method 2 would be the mathematical method. What would we multiply by? The first time we would have how many out of how many, and then times the second time we would have how many out of how many. Who can help me set up that multiplication problem? How many kids do we have, you guys? 5. Out of those 5, that's my total. Out of those 5, how many are girls, you guys? 3. Okay, now I'm going to multiply. If I pick a girl the first time, how many kids do I have? How many kids do I have after I pick a girl, class? 4. I've already picked 1 girl. How many girls do I have left in the mix? 2. Okay, so that simplifies to 1/2. Do I still get 3/10? Yes. You can use either method. All right, we'll finish this tomorrow along with tomorrow's lesson. Your homework make sure you take your notes home tonight. Your homework is workbook exercise 5.